Welcome to my YouTube channel. In these tutorials, you'll learn how to model a twist bridge using Robot Structural Analysis Professional 2025. This set of tutorials will guide you through the complete modeling process of the twist bridge in approximately 35 minutes. Still, you can also follow each tutorial independently at your own pace. Before diving in, don't forget to subscribe to my YouTube channel and click the notification bell so you can be among the first to know when new tracks are uploaded. Your support means everything. If you want access to the training material, please apply for a YouTube membership. Training material is always available exclusively for YouTube members. Create the structural axis and set the twist bridge height and width. Learn how to create a structural axis as the basis for the columns and beams grid. In the structural axis dialog box, on the X tab, set the position to 0, number of repet to 30, distance to 1, 5 meter and numbering to 1, 2, 3, and then click Add. On the Y tab, set the position to 0, number of repetitions to 5, meter distance to 1, and numbering to ABC, and then click Add. On the Z tab, set the position to 0, no of repet to 5, meter distance to 1, and numbering to value, and then click Add. In this step, you will learn how to add and model steel columns and beams. We will cover the process of placing structural steel members, copying them across the length of the structure, and renaming each element accordingly. The modeling of steel columns and beams at both the starting and ending points of the structure has been successfully completed. This marks a significant milestone in the overall modeling process. In the subsequent phase, we will proceed to establish a new set of structural axes in order to accurately determine the center of the structure. Additionally, this central reference will play a critical role in maintaining alignment and precision throughout the remaining stages of the project. To facilitate this, auxiliary geometric elements, such as circles, may be introduced at the beginning, midpoint, and end of the structure. Moreover, small steel members can be utilized as visual and structural guides, serving as essential reference components in the modeling process. With this foundation in place, we are now well prepared to advance to the next step in the modeling workflow. Let us now proceed to the next stage in the modeling of the twisting bridge. In this phase, we will focus on creating the curved beams, which are positioned at the top, bottom, left, and right sides of the structure, effectively forming a complete perimeter in 4 directions. To achieve this, we will utilize a curved object, which will then be subdivided into 13 equal segments. This approach enables precise placement of curved beams across all 4 edges of the bridge framework, ensuring both symmetry and structural integrity. Completing this step marks a significant milestone, as it constitutes the primary structural form of the bridge. More importantly, however, is the use of reference geometry, specifically, the reference circle, along with small steel beams and columns placed at the center of the structure. These elements play a critical role in guiding the layout and maintaining spatial accuracy, both in this step and in the subsequent modeling processes. Modeling the cross beams. We have successfully completed the modeling of the curved beams. Well done. Now, it is time to proceed with the next essential step, modeling the cross beams in all four directions: top, bottom, left, and right. This process is straightforward and highly intuitive. We will begin by modeling the cross beams along the top and bottom, followed by the right and left sides of the structure. By following the steps carefully, you will find this task simple and efficient. Stay with me as I guide you through each direction step by step. Let's begin. The modeling of the cross beams has been successfully completed. We can now proceed to the next critical phase, the modeling of the main bridge. To initiate this process, it is essential to establish reference axes along the three primary directions, X, Y, and Z. Let us proceed by defining these axes to ensure precise alignment and accurate modeling throughout the subsequent stages. In this phase of bridge modeling, the first step involves modeling the main beams for the bridge structure. Once the main beams are in place, we will proceed to model the secondary beams in the shorter direction, followed by copying them along the length of the bridge to ensure proper distribution. Next, we will define the reinforced concrete slab, 200 mm thick, positioned at the top of the bridge structure. Upon completion of these components, we will move the bridge structure into its final position. At this stage, we will create additional axes along the main bridge to ensure alignment. Once the axes are established, we will adjust the bridge's placement within the overall structure, marking the successful completion of the modeling process. Throughout this tutorial, we will also explore the option of modifying the cross-sections of the main bridge. These adjustments will be demonstrated as part of the modeling process. Let's get started. Congratulations! The modeling of the twisting bridge has been successfully completed. We have now entered the final phase, running the analysis and evaluating the displacement to ensure the integrity and accuracy of the model. Upon reviewing the analysis results, it is evident that the displacement values fall well within the acceptable range, well below the prescribed deflection limits. This strongly indicates that the modeling process has been executed correctly, and the structure is now fully prepared for load application and subsequent design phases. With this, we have concluded the entire modeling process. I sincerely hope that you found this tutorial informative and valuable. Please remember to subscribe to my channel, share this content with your peers, and offer your continued support. Should you have any inquiries or require further clarification, do not hesitate to reach out. I am more than happy to assist.